Thank you, Bruno and Ugo, and also Nina and Olga for very nice presentations and showing the richness of the possibilities you can do in these fields. So I would like to the audience to join, because we have like half an hour here time, and I would like to go back to this previous panel, in the sense that Olga was asking a very nice question, but it was interrupted quite brutally, actually. So why don't we go back to that, because I think it's very much to the topic. And so if you can remind us about the question, and maybe we can continue.
Okay, I will remind you the question, and then we'll try to, if you want to discuss and maybe connect with the topics we discussed at this panel. Let's try. But yeah, I just have a question. I don't have answers, but yeah, it was about this distinction Paul Turner proposed between mathematics and art, like trying to distinguish them by saying that mathematics is concerns more with universal archetypes and arts more with examples of archetypes. And I'm not sure I view it like this, but I think it's an interesting way of seeing things. And I also was thinking about this balls that Indira presented, which are squares. And I think this is a classical example of a non-archetypical example in mathematics. Like a ball is a square, what happens? And I think in mathematics we are interested sometimes in these examples, like some kind of bizarre things, like okay, I would like to understand what happens, and I look not only at a general tendency, but I look at some extremal cases and try to understand the world. And I think it can also happen in social science when you study some typical drawing and you see that people go up because we learn to write over the line and not under the line, I suppose. But you also are interested in people who go very high, and you kind of want to know what people do many circles and who go straight to the end, like how often happens a long curve, what is the mean length of the curve, etc. Yeah, I am. I don't know, I'm not sure we can distinguish art and math as simply with this idea of archetype, and even like just defining archetype, I'm a little lost. I think this semantics point of view is very interesting, because there is a common language and there is a mathematical language, and we as mathematicians, we are also human, right? So if you show me, for example, a model of a cube which is made with like 8 balls connected with sticks, you show me to me and you say to me, is it a cube? I will say yes, and then I'm like, oh no, as a mathematician I don't agree. The cube is not that, right? The cube is a surface. But when you ask to me if it's a cube, I will say yes. So we are at the same time, right, mathematicians and humans. So we, the same object, and we speak about mathematics also when we discuss mathematics, we do research in mathematics. Sometimes we don't call a cube, right? Sometimes we call one skeleton of a cube. But we suppose that we all understand that we are speaking about a cube. I don't know if it makes sense, but and I suppose artists do this as well. So it's a big mess, and I think we need somebody who observes this to understand what happens. It's very hard to question your own practice, and sometimes we reach the limits of it. Yeah, I would be very happy to know what you think, and maybe. In relationship to this panel, when we speak about with audiences also, with people who come from somewhere else, myself personally, I don't want to impose to them my vision of mathematics, because sometimes we have very different backgrounds, and I feel like what you were speaking, all of the speakers here, I would like to know what you think, like how do you, what do you do, how do you, people come from somewhere else, what do you tell them about mathematics, or do you let them explore? What is your strategy? Because you all have so much practice about that, right? So you have strategies.
Maybe I can start. So with Hugo, our principle is very easy. We have 10 seconds to catch the audience interest. So we don't say a lot of things. We just ask, oh, do you want to participate? Here is what you need to do. And then you wait. And you wait for them to come back to you. After some time, they will say, but why are you here? Why are you mathematicians, say, in a game festival or whatsoever? And then you can start talking about with them. And also we try to have activities that can be approached with several levels of abstractions. So you can talk about drawing curves with kids or with bachelor students. You just don't use the same words and the same abstract level.
Yeah, so as usual, I agree with everything Bruno says. So I don't have much to add, but as a concrete example, like when you look at the curves, then you can respond or answer a question by somebody who's trying to understand what's going on with the curves, like for instance for the colors, in different ways. So you can start by saying, well, in fact, the zones are not colored randomly, but they're colored using some mathematical principle, and then you can see whether the person wants to know more or not. And very often the person does not want to know more. So this is typically the mistake that I think, I mean, mathematicians make, but probably experts in general in other fields make, is that we have a tendency, if you know something, and you are going to tell what you know to the person in front of you. And this, at the level of mediation, is a disaster.
Yeah, I completely agree with this. So my strategy would be more on coming with some concrete objects. I remember one event, I was invited to fine art school to give a couple of workshops, and what we did was some origami and crocheting, and somehow I was super scared in there, because I was, what am I doing? I'm with my kind of poor skills on crocheting, and I come with these origami things which are not super, just some. So what am I doing here? This true artist, and what is going to be? But then eventually, somehow the ice was broken when I just brought the samples, and they took them and they started to study, and amazing questions, and this was, so I didn't even try to explain what I saw in them and what they were like presenting, where they came from, but I let them to ask the questions, and super interesting discussions came up from this. So you need to give this some kind of space and time for things to happen. I think in every event it's that's something you need to have to build some contact.
My turn. My approach, it's quite a hard question. I think it really depends on the environment, how many people, how long, and what and why, and how old are they, and do they like math, do they hate math? It will really change what you do. But I think the thing I do the most is having a school group, that are coming to us. And first, there's no way you can hide the word math, because they are going to a place that literally there's the word math in the title. And every now and then I'll start by saying, okay, do you know what you're going to do today? And they say, math? So there's no way you can, get away from that. But I do try to avoid it as much as possible and just say, okay, we're going to do an activity. And usually we always start with something they've got to do, and maybe they're going to play a game, or they're going to try and solve something. And there's always a point where someone will say, excuse me, why is this math? And what has this got to do with anything? And that's always a very hard question, because it's never very easy to understand, because you don't want to completely break down the idea that the math they're doing in school, it obviously is math, but it's so different. It's difficult to kind of create a connection with those worlds, and depending on the context, I will either try to just not answer too much, and sometimes I will, but yeah, I think just not trying to say that it's math. It might sound like a bad strategy, but it does work, because at the end, they know they were there to do something related to math, and they know they thought it was interesting, and they maybe, you know, they understood something, they did stuff, and they will associate that hopefully with the idea of math, even though I didn't like make a whole sentence about it.
I completely agree with what Nina says with respect to street math. I'd call it street math, but when we do it, this is the same strategy, like say that it's math, but as late as possible. And people actually, when people come back, buy some drawing, some people would take chalk and say, can I draw nearby? And they draw their stuff, and that's totally fine. And some people will go a little bit outside the algorithm and do some things that's also totally fine. Yes, but there are some limits. For example, for Sierpinski triangle, it's not possible, because if you know that if you make a small mistake in this addition modulo 2, it propagates very quickly, so there is some respect to the algorithm. But we don't say it like this. We say respect the work of others, because this is the thing we want to share. And for example, for mandalas, when you want to just work on symmetry and circles, etc., actually it's very hard to draw a big circle. It's a pain in the back a lot, because anyway. And if you draw some pattern, you have to repeat it in every sector of the circle. And this is something we impose because it's what we want to share. But there is this thing you want to tell to people, yeah, it was math because of this and this and this element, so they construct some positive experience in relationship to mathematics, because school is not often the place to make mistakes, to create together as well. And many people, their only experience of mathematics is that of the school. So there is this cultural education that is done like this. So we have to say this is also math. But for me, it's also like, I don't know how you look at it, because there is also some danger, right, to say everything is math, right? Because we don't want to put a mathematical label on something that is also many other things, right? It's also like an expert's problem, I think. If you are expert in dogs, you see everything as a little bit a dog, right? And I think this is like in mathematics, right?
Yeah. Okay, I think we are somehow talking about very much this similar things, but formulating it in different ways. And what I find after this kind of experiences with art people is that the thing that we are, as mathematicians, the biggest mistake somehow what we are doing, that we have a lot of need for communication or communicate about something we have found, something super interesting. We have definitely a story to tell. And we want to cook up some visualization, and sometimes we want to ask, like, okay, would some artist come to help me and put it so that it looks nice, because of course in visual arts people are experts on this how things look, and but that's only like very artificial layer, and they might not be at all interested on your message and what is the thing. But it can be a starting point to something, some kind of artistic. But then it's also critical for mathematicians. It's I think difficult to accept this, that you will take it to some direction which is not correct. And this is kind of continuous, like. But we can go back and forth, but we need to somehow be patient with this kind of. And it's also always like, I think that it should work in both directions. So, and give like space for these things to happen. What I have been discussing with one of my art colleagues is that comes back to this earlier panel also, that you were talking about the differences between art and mathematics, but are there anything like similar in research or thinking of these disciplines? And we came up with at least one which we could agree is something that when you do artistic research or research in mathematics, it's completely okay to study useless things. So you don't need to have any goal for certain application or something that you should somehow see the final outcome like immediately, and then you just make some kind of process into that. That's completely like opposite. It's kind of this process. And you were talking about this Julie Pick or Sophie?
Sylvie Pick.
Sylvie Pick, yes. There are similar, I know at least Eva Hild in Swedish sculpture. She's also making amazing sculptures, and it's very difficult to, for example, to come up with, so what is the topological type of this? And I don't know how she makes. I think it's the same as in your experience. That would be nice to understand the process that's behind. But for some reason, art people are not always willing to tell about that, or we don't have. Maybe we haven't found language to somehow share this experience. But are there any questions from the audience? Oh, several. So maybe you first. Yeah.
Thank you very much for a fantastic presentation, super interesting. I'm running a risk of being disliked possibly because I'm going to bring the subject of AI. Have you had the chance, any of you, to experiment with AI, and is it working, is it not working? Feel free to give a short answer if you're saying no or yes, and you know, because I can imagine we can talk for days and weeks probably about the subject. So I'll leave it there.
I mean, at least for like the curves, this is certainly something we've thought about. Our original motivation actually for this project was of course a wink to AI in the sense of large data sets, but also like opposing human intelligence to artificial intelligence. I mean, it had both aspects. Like the collaborative creativity, of course, goes exactly in the direction of harnessing lots of data sets to try to produce something meaningful, but explicitly getting as opposed to random data sets or other things, like to really use human data sets sort of to oppose this. But so the short answer is yes, we've thought about it, but no, we haven't used it yet. And yes, we probably will at one point.
Okay.
At least for us.
Okay, thank you.
Yeah.
You want?
I think it depends if you mean using it to create things, or of course we do a lot of activities about AI to just explain what AI is, because if everyone thinks about it, it's also because a lot of people have questions about it and how it works. And that's actually quite a difficult thing. But the previous exhibition was about artificial intelligence that we had. But when I create, we really don't use it. I have tried a few times when I had no idea to ask ChatGPT, and terrible results, and I thought I still have a job for quite a long time, because it's really not great when you ask it to like imagine an activity. But it's very funny though, and then I start having ideas. But yeah, no, I really don't use it.
Yeah, I have quite a radical approach to AI concerning what I do, because I do mostly writing. I did a blog on mathematical stories of mathematicians in Russia, and I did write some scripts also for movies, and I tried, of course, ChatGPT in the difficult evenings, yes, not conclusive, and but I mean, I even don't use the programs that, for example, when you write some text that would correct your writing, etc. Because I spoke with some sociologists, which probably influenced me too much on how the AI works based on collection of data, and with all the biases there already in the data. I kind of try to resist on my personal level to this, even though my French is not perfect and will never be perfect, and that's life. I decided to accept that, and even like the mistakes that I do in articles in French and in English, certainly I just live with them, because I think it's concerning the writing, right? Concerning the writing voice, for me, these imperfections are actually the presence of human in writing, and I want to kind of to be on this side of the battle, right? To have the different voices, to kind of, if you want, feed the AI for the future, to have this text coming from different perspectives. And I think that we really need to create new stories, new ways of speaking about mathematics, because even when we speak of archetypes, to relate to the first panel, and of gender, for example, we can also ask questions of race, ask questions what kind of mathematics we are sharing, what kind of archetypes we are creating, how the archetypes we think about are related to Western culture, etc. And what kind of mathematics we forget, which actually existed. And I got the question, last time I got this question, it was in Saint-Denis in Paris, in a popular quartier populaire near Paris, and we spoke about what kind of mathematics are forgot. Like there is this area of studies which is called ethnomathematics, of studying what are mathematical practices. To give one example, for example, the kolam practice in South India, women who draw with rice different patterns of closed curves, and you can study it from anthropological, historical perspective, etc. And ChatGPT doesn't really find the stories, right, for now. Maybe one day it will, but I think we have to work a lot to keep them closer to us, and like, I mean, to tell our stories, our personal stories from our perspective, which yeah, and I think it means a lot for me that like many projects I do are the stories which are not yet told. I really think we have things to work on. And I have no problems with Gauss and Euler, right? So no problem.
So I just want to add that the danger with AI is that it tends to be stereotypical instead of archetypal. And it's difficult to say.
Yeah, please.
Just to end with AI, the question I have the most often from students, if I ever talk about any problem, and if the worst thing is if I say it's an open problem, they always say, well, why don't we just ask ChatGPT?
Yes.
How come? And that is, and then you suddenly realize that they think that it's this thing that is like so powerful and that has the answer to everything and that understands everything. And it's really hard to convince them that ChatGPT will not have the answer. And I'm like, well, you'll go home and try if you want, and you'll see. But they do see it as some perfect super intelligence.
Yeah, so I can also give actually one example, which this AI is not yet developed like enough, and it's related to origami. So if you see some kind of, so do these steps, if it's generated by AI, it's just grab. I mean, it's no instructions. It may be some repeated, something. So behind that is that mathematically we don't understand them well enough yet. So that's very much encouraging to do research towards origami as well, so that it would be possible to then create also these instructions, this kind of algorithm for how to make these steps. That's super challenging for AI. So there was another question behind.
Thank you to give me the opportunity to say something. Yes. So, more like this. Yeah. So to talk about the difference between art. First I want to say I heard a lot of nice things from you and also the other panel. But what is my comment is, in order to discuss the difference between art and mathematics, me at least, I need a definition, and I don't have a definition of art and a definition of mathematics. I don't have. But what I like most is to see what they have in common. And in order to explain this, compare both with swimming. You don't go to a library to learn how to swim. Practice is more important. The same is true for art and for mathematics. Thank you.
No, I mean, I don't go to a library to learn to swim at all, but I agree completely. And in fact, this is sort of what Bruno was also hinting at, is that all of the, at least at the level of outreach activities that we do, is always that we immediately ask people to start swimming, and then we see when we see them drown, then we try to pull them out of the water so that they don't leave the swimming pool with this feeling that swimming is really the worst possible activity on earth. Yeah.
Okay. Let me just.
Art and mathematics, but this difference is only related to today. Today, art is not used to do selection in the school, but mathematics is used. So I prefer we do more art or more Latin or more some other thing instead of mathematics to do selection.
Maybe to point an elephant in the room. Indeed, art and mathematics have things in common. It's the construction, the elitist construction of both of them. I agree that mathematics is more present in the school construction in France, especially. There is a work of Margot Dehache, who is a sociologist who worked on it recently. But the distinction operated by art has been also studied by sociologists. I can name only one, Pierre Bourdieu, but there are many others. And it's true that people who do outreach, we know it and we fight against it. That's the elephant in the room. Like, we know it. Nina can speak about when she goes to different schools. Not all the schools are the same, and we know it and we work with it. And when we do street math on the streets, it's not true to say that anybody comes to draw. It's not true, because there are people in the streets that don't feel welcome to draw something on the public place, and there are people who are feel very confident and come to us and say, "Oh, I've been to engineer school and I know that it's a Sierpinski gasket, and I can tell you where there are the empty squares and where there are full squares." And there are also people who would come to me and tell me that they spent 15 years trying to battle with mathematics and were very sad, and in the end they would almost cry at me, like, "Why do you do this in public place? How can you impose it?" And there is lots of violence that can come out even in these joyful pictures, and all of that is the consequence of how mathematical system is constructed, and how there is a lot of symbolic violence in the way that we share mathematics if we don't make precautions. And I think we all make mistakes with that, and we all want to get better at that. And art is also historically constructed like that, and I think in art there are also people who would fight that, but institutionally we have a lot of work to do, and in art and in mathematics, to make the things better. And it's very different from swimming, right? When you go swimming, nobody asks you what diploma you have in swimming, right, to be able to swim, this is the big thing that I think relates art and math. And it's an obvious truth which relates art and math. Maybe there are some other things, but this is the most, I think this is the most present and the most strong. And if I may say, I think this is why, maybe this is the most clear reason why art and math meet, because we have this symbolic, cultural, historical construction of our domains, which are like this. But I believe we should fight it as much as we can to evolve our practices. Maybe Nina, you can tell something about how you go to schools in the north of Lyon.
There are other questions.
Okay.
We have only a few minutes time, but we can take questions.
I just wanted to add something. You asked everybody before what are techniques to get to people and to get them involved. And I think what you said now really is very fundamental. So a lot of people coming to you bring their baggage. And I think one technique or one thing, especially with school classes, is that you have to make them feel at ease at the first place. So they have to trust you. So I think that that's the first thing which you have to keep in mind. They come, they know they will do something about mathematics. They had a test the other day, which is not well, and at home they see school not very in a positive way, and also all these elitists, and then they come to you, and this is, we have to keep this in mind when they come, and then you have to get their trust. They have to trust you, and you have first to get a moment where they are open and that you can talk to them. And I think this is very, very, very important when you do activities, especially with young teenagers who are not yet on your side. It's really important, I think.
Okay, thank you. I think it's already, our time is up. I want to thank the organizers once again, and also encourage you to go to look at the exhibition. It's fantastic that you have this kind of unique place here at EPFL, and hopefully it will continue also in the future. So thank you.